I'm going to talk about deep learning for time series and particularly applications of it in industry. This is actually probably, I think, the third time I think I've talked about this subject at various presentations, but don't worry, I'm not going to just rehash what I've said at other presentations. I'm going to go into a lot of new areas today I haven't previously discussed. Though on that same note, if you haven't seen some of the previous presentations, I will briefly recap them so everyone will know what's going on. So without further ado, I'll get started. So first of all, I'm also the author and maintainer of a deep learning for time series forecasting framework called FlowForecast. FlowForecast, as the name implies, originally started out kind of as a framework specifically for forecasting flash floods and river flows, but I expanded it to be a general purpose framework, and likewise other contributors to FlowForecast have added a lot of great features that are good really for any kind of time series forecasting work. And so that's been true for the last couple of years. And then most recently, actually within the last 2.5, 3 months, greatly expanded the support. We've greatly expanded the support for both time series classification and time series anomaly detection. So that's in particular what I'm going to kind of go over and talk about today. Yeah, that's FlowForecast. So I will briefly, as I said, recap what that delete selected applications thing is. Maybe not everyone can see that. But yeah, as I said, I'll briefly recap kind of what FlowForecast does, as well as some of my previous presentations. So actually this slide, if you saw my presentation at TWIML Fest, which I believe was in October 2020, I kind of went over things I frequently hear people say about deep learning in the time series forecasting or time series analysis space in industry. So oddly enough, particularly recently, there's almost been a pushback against kind of deep learning and a preference for simple methods, particularly in industry. Obviously, it's completely different in academia. So in that talk, I really went over some different things that I frequently hear and why I thought they're wrong. So that's what that talk really focused on. So to briefly recap some of that, again, not spending too much time on this, there are significant performance improvements we see when using deep learning compared to classical models. Number two, there's also seems to be a still very prevalent kind of false dichotomy, or if either I can use a deep learning model or I could use an interpretable model. So a lot of people, I think, still think that deep learning models are inherently not interpretable. Whereas there's actually been a lot of advances in deep learning interpretability methods over the last few years. And that's really what I kind of dived into a lot of detail at that second presentation last April, I believe. I really kind of reviewed all the different interpretability methods FlowForecast supports and how you can use them to interpret your deep time series models. But this is just kind of a brief overview. I'm not going to rehash that all today, but if people are interested, they can watch that other talk. The other thing I've talked about a lot and gotten a lot of feedback on the FlowForecast library on is a lot of people don't really like using configuration files. However, I think, and people have actually gotten used to using configuration files generally like it a lot. So basically FlowForecast is built around the idea of using a configuration file in JSON where you define your time series forecasting or time series classification experiment. And it's a lot easier to track results across lots of different experiments, particularly when integrated with weights and biases. And it gets rid of a lot of the problems with like a lot of spaghetti code that other frameworks have, where you're writing a lot of code and then none of it's trackable or reproducible. So that's really one of the core things we use at FlowForecast. And yeah, I've had a lot of feedback with people saying, oh, why can't you just have like an sklearn like API? Well, it is true for a lot of like deep learning experiments. We have a lot more parameters to manage. So there's actually a rhyme and reason for us using configuration files. So yeah, with that said, I'll use this moment to briefly move out of my slides and into what some actual configuration file very briefly. As I said, this talk, I want to definitely focus a lot more on real world applications. But just to get everyone familiarized with kind of how we use configuration files in FlowForecast, I'll go through this basic like tutorial that we usually direct people towards first when they use FlowForecast. This top stuff is pretty standard installing the thing. You can also install it as a pip package. Here I'm just using a very easy to use traffic data set that has the flow rate of traffic in different lanes. And so here's kind of these configuration files I'm just talking about. Most of your FlowForecast, pretty much all of your FlowForecast use will begin with using a configuration file like this. So here we define a model name, a model type, and also a set of parameters. And so these are the different parameters that go into the model. Some of these we're actually running a sweep over here, which I'll get to in a second, so they're tunable. And again, down through here, you have these different blocks of parameters, like data set parameters, or what initialize your data loader. Training parameters, this is where you can pick out what criterion you want to use. Or now actually we're adding support for using multiple criterion, which is kind of interesting, but I'll get to that later. Your optimizer parameters like learning rate, batch size. So basically that's kind of the core of what's defined in the configuration file. I won't go for detail about every line right now. And then secondly, you can also define a configuration sweep. So if there are parameters, hyperparameters you want to sweep over, like compare how your model does with different batch sizes, you define them here, and then they get substituted back into this main config when you run the model. So that's a very, and then here's how you would actually run the sweep. So that's a very quick, very basic introduction to configuration files. Sorry if you've used FlowForecast before, that was probably kind of boring, but I'm assuming a lot of you haven't. So that will be useful when we go over more things in a second. So briefly too, before going into the main portion of the talk, I will briefly kind of recap some of the history of using deep learning for time series research. Really around 2015, maybe even a bit earlier, but this is where when I started looking back and some of the, I guess, history of it, you start really beginning to find, you know, LSTMs, GRUs, these types of neural nets kind of emerging for time series forecasting and classification as well. Then basically a bit later, we get more kind of almost like these hybrid models that use both, you know, an LSTM and have a recurrent mechanism, but also have attention layers, which were also becoming popular in natural language processing. And then moving on kind of towards the present, we're really seeing a bigger crossover, particularly on the NLP side, where like from the NLP side, where like more models like transformers or variants of transformers and self-attention are becoming prevalent in kind of time series forecasting and time series classification. Actually, an even more recent trend that I haven't really added here is also the prevalence of GNNs or graph neural nets to really be able to better utilize some of that geospatial data. That's very recent though, really starting probably all the way back in probably just in like December or January of 2021 is where I saw some of the first papers, like major conferences on that. I'll briefly talk about that later. But so that's just kind of an overview in history. Now I'll go over kind of like the meat of like what today's talk I'm going to discuss. So I'm going to go over using FlowForecast for kind of forecasting, classification, anomaly detection, and utilizing these time series embeddings. Really, the core is going to be focused on these real world examples. So yeah, I don't really find too much interest in using kind of toy examples, as I assume most of the people at this talk are probably coming from a business side or a place where you have a lot of real world complex time series data that isn't trivial to use. So I'm going to spend most of my time talking about these examples. Then I'm going to go a bit on about FlowForecast under the hood, how it's structured, things we're trying to add to FlowForecast. But you know, as contributors, we're really overwhelmed, and so we don't have a lot of time. So that's where it would be great, like if some of you in the community had time to contribute to our open source project. And then finally, I'll go over kind of any questions and feedback people have. So yeah, without further ado, I'll jump in. So first, I guess it's good to just clarify terminology. These are probably not like academic rigorous definitions of these things, but this is kind of how I think about things and pretty much the terminology I'll use when talking. So basically with time series forecasting, you're trying to predict the future value of some target variable at a certain time, usually using the historical historical values of that variable, plus potentially other variables like covariates. And you can have different forecast histories and different forecast lengths. So like in FlowForecast, we use the term forecast history, which is the number of historical time steps you pass into the model. And then the forecast length is the number of time steps into the future you forecast. Then moving on to classification. I assume most people know basically what it is, but you would have some different sequence of time steps and different data at those time steps, and you're trying to assign a label to those. Kind of a variant. I mean, I don't know if this is actually changes the definition at all, but I also often use time series classification to when I'm like talking about, oh, I want to forecast what the label will be at a future point in time. So it's almost like forecasting, but with direct labels. Really, there's not much difference there, but sometimes people use time series classification to like apply directly to the state of a time series sequence now. So I kind of use the two interchangeably. So that's something I occasionally do as well. Time series anomaly detection, really, well, at least in the supervised case, time series anomaly detection is really just an extreme case of time series classification where you're trying to assign a binary label, usually 0 for normal or 1 for like abnormal, to basically a sequence of time steps, and there's usually a disproportionate amount of your normal data, orders of magnitudes more. So a true anomaly detection problem, you might have like 1,000, 1,000 abnormal labels out of like a total number of 100,000 time series sequences. And then finally, as we'll see, there's a lot of overlap and interplay between these. And so, yeah, that's basically the terminology. I guess also I'll quickly add for time series anomaly detection, you can also have unsupervised, which is where you're just trying to create representations of the time series data and then use some kind of like cosine similarity or some other metric to be able to automatically see if the one representation isn't like another, because in that case you wouldn't have labels. So yeah, so first thing first, river flow and flash flood prediction. Basically, I always hesitate actually to start with this example because for the most part, I'm often trying to convince people that FlowForecast is a general purpose time series forecasting framework, which it obviously is. But the simple fact is I have used it probably the most for river flow and flash flood prediction. So it's a pretty meaty problem, so I often like to dig into it just because I have the most data on it. Yeah, obviously flash floods are probably one of the worst natural disasters, at least that over, out of the weather related natural disasters. I don't know if you could classify a pandemic as a natural disaster, but that's another discussion. So out of, weather related natural disasters, they're one of the kind of worst in terms of loss of life and property damage. Better prediction of kind of flash flood events and timely alerts is pretty essential to like helping to mitigate the damage, especially in like certain areas where people, it might take a while for people to evacuate the area. So yeah, on that note, one of the problems I focused a lot on recently was I had temporal time series data of the river flow of the, oh, did I not finish that slide? I guess I didn't entirely finish that slide. But anyways, so the Virgin River is basically a river that runs through the heart of Zion National Park. If you've ever actually hiked there, basically you can actually hike down the stream bed, and most of the time it's fine. It's like never higher than like knee or waist deep. But occasionally it does flash flood, and being in a canyon, big flows can come down it very quickly. So yeah, I'll jump out of the slides again for a second here. Basically, I showed this notebook, I think, in one of my other talks, so I'll just show it briefly here. But this notebook kind of, which is actually a weights and biases report, basically gives kind of an overview of the problem and different kinds of ideas. So this was kind of my initial different kind of methodology on using different neural networks to forecast it. And what I found was, well, actually, while I'm here, I'll describe what some of this stuff is. So this is weights and biases. FlowForecast natively integrates with weights and biases. So, and weights and biases is basically a hyperparameter tracking platform. And it makes it really easy to track your parameters and also create these reports based on how things run. So these are just basically how different parameters like the length of the forecast history are impacting the loss. Here actually red is better because red means it's causing longer, like forecast length is causing like the length is causing the loss to decrease and whatnot. So that's kind of that. I won't go over that in a ton of detail right now. But anyways, here's different parameters. And anyways, one of the things I found was some of the models seem to actually predict the river pretty well within the different confidence intervals. But then essentially, what happens is that when you actually go to look at like some of the most extreme precipitation events, the models fall apart and don't really forecast all that well. So for instance, yeah, here's a model that previously forecasted well, but here it doesn't really model the spike. That's like the sudden spike in the river flow due to an extreme rain event. I think none of them really modeled the exact way the river spikes up. So basically, oh yeah, this is an even better example. So even these models that like do well under normal conditions aren't modeling these very like abnormal kind of flash flood type conditions. So I'll go back to PowerPoint, I think now. So yeah, that's kind of the overview of some of the issues I was having forecasting that. So one of the, then one of the models I decided to try to use was the Informer, which is kind of a new state-of-the-art deep learning model that was released at A triple AI. And yeah, it's a very interesting model. Unfortunately, it was very hard to work with. At times I felt like I was banging my head against the wall, but it is now fully supported in FlowForecast, so anyone can use it. The bad side was, unfortunately, we can look at some of the results. It didn't seem to really be able to learn the pattern of the Virgin River well at all. So even though here the loss decreases as problems learning this kind of unskilled validation loss, and its forecasts look pretty terrible. Nevertheless, I kind of kept trying to use it, figuring I was doing something wrong, but until eventually I actually found another paper that also looked at using the informer for kind of climate and meteorological forecasting, and they also had a lot of kind of problems, so to speak, using it for that. And then I kind of went back to some of the other models I was using. But I think the whole interesting thing about this is that, like, even though that there might be, like, you know, a deep learning for time series model that works really well in one area, it might not even outperform, like, say, simpler models like DARNN in another. Like in NLP, it's like much more standardized. You have like the core transformers, and they pretty much always outperform like LSTMs or RNNs. But in time series, it seems a lot more fragmented depending on the exact problem, which is why I think, us at FlowForecast are so good, because we allow you to easily switch between a lot of different models without much overhead, if you're willing to do that, that is. So then I kind of went back and actually redefined some of my goals and priorities. Actually, it was interesting. I was on a long road trip kind of out west, and I actually went and hiked down some of these dry washes and canyons myself, both in Zion and also Capitol Reef. And I really saw that, like, some of the really important stuff like wouldn't be predicting the exact flow or precipitation, but really kind of impact for kind of detecting the precursor to an extreme precipitation event, and exactly where that precipitation event is going to occur. Because particularly for some small slot canyons, if you're like canyoneering down them or hiking, like if there's like a thunderstorm, and even if it's 50 miles away, if that's the drainage area drains into that slot canyon, it's going to cause like potentially drownings in it. So I kind of looked back and basically then said, I'm going to try out this idea of using multiple weather stations and kind of multiple different rainfall data all around kind of the river basin area, and then using that to also forecast the different flows at kind of each different precipitation at each station, and also kind of do a joint anomaly detection and time series forecasting problem. And actually, this is something I haven't entirely finished, so I don't have like tons of great drawn up results on it. But I can show you actually the notebook and how this will now work in FlowForecast. So basically, here's actually this. So yeah, this actually isn't 100% yet supported in FlowForecast. So you're seeing some of the real like cutting edge stuff we're adding, but we're actually adding support so that you can do joint time series forecasting and anomaly detection in one model simultaneously with different criterion. So this is a much more complicated configuration file. I showed you a very simple one before, but here we're using kind of a transformer decoder. Then we're going down, we have early stopping going, which is another parameter you can add. I hope everyone can see this okay. I'll zoom just a bit more. We also have a number of targets we're forecasting for. I'll get to that more in a second. And then we're actually using here multiple criterion, because right here, we're actually trying to forecast the cubic footage, the precipitation, the dew point too. And then I create a rain label for anomaly detection, which basically says if there's going to be rain in the next 5 hours, any rain, it's going to have a value of 1. Otherwise, it's going to have a value of 0. And even then, the kind of labels where there is no rain greatly outnumber this. I think there's only 2,700 values where this rain label is 1, and there's something like 54,000 where it's 0. So it's not a huge anomaly detection problem, but it is anomaly detection. And now we have multiple criterion too. So for each basically thing we're forecasting, we have a different mean squared error. And then for the rain label, we're actually using a BCE loss legits, which is basically a binary classification loss function. Another thing you can do that we're also adding is focal loss. A lot of people think of that with like computer vision, but basically focal loss actually helps with basically very skewed different labels for an anomaly detection. For anomaly detection cases or extreme multi-class classification cases. So that's something you can do. And as I said, everything in FlowForecast, all it requires to change like a criterion is to change it in the config file. So if I wanted to swap between this and the focal loss, then I could just change it like this. Likewise, if I wanted to use mean percentage error for the loss for one of these, I could just put MAPE here. Similarly, you could pretty easily use like vanilla SGD here in your optimizer. So that's kind of what those configs will look like that allow you to really utilize a single model to do both anomaly detection and time series. And by jointly optimizing the two, I haven't done a ton of results yet with this. I am finding that it seems to work better in some of these extreme events. Let me go back to my slides. Then the other thing I worked on too is also basically I don't know why I went back in there since I'm just going to go to another notebook again. Was basically to learn the representation, to better try to learn the underlying representation of kind of both the river and then also the climate cover right before like a severe rain event occurred. And so doing this, I create a kind of autoencoder. And you can actually create time series autoencoders in FlowForecast for representation learning. It's something that's not very well documented at this point, but you can definitely do it. Oh, I see. Actually, I'm still on the first problem, and I'm already eating up kind of a fair amount of time. So I will get moving. But basically, the idea of this was to create an autoencoder that squashed the temporal kind of time series data into a single unified representation, a single kind of step representation. And then using that representation, you could compare different states of the like surrounding time series data. So in this case, specifically different states of the of the river dew point, whole kind of river climate temporal data. So that was that. I actually did get some interesting results over it. I don't think I actually linked to it though in my presentation. I'll post these slides. Actually, I'll post them on the FlowForecast discussion board so everyone can see them later with updated links and stuff. But yeah, I will get moving to the second example so I don't run way over time. So another area I've worked a ton on is COVID-19. I was actually part of the Corona Y, which is kind of a nonprofit group of AI researchers formed to apply machine learning to COVID-19. And as someone who specializes in time series, of course, I was involved in forecasting cases, deaths, and other stuff like that. And so these were kind of our core goals in this endeavor. So one of the things I worked on was also kind of classifying what the future like severity score of different counties would look like. So specifically like if a county would, so the severity score was based on like the positivity, which is the number of cases that have the percent of tests I mean that are coming back positive, along with the number of cases per 100,000 residents. I don't actually think I included the link to that notebook here, but that's an example of classification, time series classification, where you're trying to kind of classify a future, almost like that, I guess, thing I was talking about later, which is the classification of a future value. So you're trying to classify what the severity score will be based on this historic data. Usually in that was what the severity score would be like over the coming 2 weeks. So yeah, another thing I did a lot was a joint model to forecast COVID-19 cases and deaths. But something, of course, this ran into was both things like the Delta variant kind of broke this model down initially until you get enough data on the new variant to so that it forecasts accurately again. Also, just changing lockdowns and not lockdowns. Actually, by now the models learned that pretty well. But for instance, when we were trying to forecast COVID initially, and we only had data from when most like big cities were in full lockdown. And then suddenly places came out of lockdown, the model didn't generalize well. So this is kind of a major issue, like is figuring out how to have the model like, adjust to like these like, defining events. Because whether it's COVID or other things, there are going to be certain things that kind of shift the whole temporal sequence, so it's no longer related to its temporal history. So one of the ways, I kind of looked at doing some of that was one of the ways I'm planning on kind of looking at it more, I guess, is by kind of doing some of that unsupervised type of anomaly detection, where you have a representation of, say, like what the like state of the what the state of the thing is, and then if what the state of the temporal data is, I guess, is a better way to phrase it. And then the temporal data, say, changes over time, you can have a distance function to automatically compute the distances and then alter that forecast accordingly. I guess right now I won't show any. I do have a lot of examples of kind of multitask forecasting of kind of both cases plus deaths with COVID. Some of these work better than others. But yeah, here's just an example of like how that logs the weights and biases. So this model jointly forecasted deaths and cases. But so for instance, this model actually did a pretty good job at forecasting deaths okay, but didn't really work as well at forecasting cases. And one of the reasons I think was that this was when like more contagious, I think I ran this when more contagious variants were beginning to spread, but at the same time, more people were vaccinated. So like, I think less people were actually dying, at least at this point, due to that. So for instance, here it maintained pretty good performance forecasting daily deaths, but it wasn't really able to forecast high numbers of infections very well. So yeah, that's kind of practical, kind of the example of like that meme I showed. So yeah, I promised to have 3 different things. So the third thing I promised to show for forecasting, I wanted to do something from agriculture Fortunately, a lot of agriculture data is closely guarded, so I can do something like really interesting, like say predicting the daily yields of milk from cattle or something like that. But like a cool public data set that's just on Kaggle that anyone can use is like avocado, this avocado price data set. It's not like a terribly like detailed data set, but actually this might be good for showing people who aren't that familiar with FlowForecast a simpler example. So in the data set, I think you have just things like, can I show the data frame? I forget if Kaggle renders the data frame, but in any case, like in the data, I think you have things just like, so this is all just the output from FlowForecast being installed. But yeah, in the data frame, you have like, things like price, the volume sold, different types of things like that. So here I just cluster for one particular geographic region. And then this is again, a simpler configuration file. So again, here's the config. Here I'm actually using a kind of dynamic thing to supply the train start and end. You can do that. Relevant columns. Yeah, nothing too remarkable. I think about this one. Oh wait, is this the one that ran? So I got that running. So with this one, I think the results, I had the result page of that. I actually just drew up this example like literally right before this talk. So because I didn't want to do like a third example besides the regular COVID and river flow examples I often use. So here again are the different kind of interpretability metrics, the heat maps. So it doesn't really look like the model is using total volume, which maybe it should be. So average price. So it is using, it looks like it is using the average price at certain different time steps to predict what the current price will be. I won't go for each and every one. FlowForecast does log a lot of different heat maps for interpretability. Wait, where'd the actual forecast plot go? That's what I'm looking for. Okay, so yeah, here, this is kind of one of the more primitive plots because I didn't run a confidence interval on it. But here are the different predicted price versus the actual price over the 5 time steps it forecasts on. So yeah, that's just a very quick example I drew up right before giving this talk. So I'll move on from this. So yeah, one of the huge things too that we're working on with improving FlowForecast. We've been adding a lot of new features. Unfortunately, documentation hasn't been keeping up, so people have been complaining about that. So yeah, so that's definitely something we're going to work on more though in the future is documentation. But I did want to outline some of the really neat and cutting edge stuff we're working on adding to FlowForecast right now. So one of these is the handling of multiple time series and ID embedding. So you kind of saw this maybe with some of the COVID stuff, or maybe some of even the avocado forecasting. And really, in reality, we usually probably want to train one model to say forecast for like in terms of COVID, forecast different counties at once without having to create separate models for separate counties, or like for the avocados, we want to have one model forecast for the different what is it for the different regions where it's sold. Like I kind of just did Chicago there. We really want to be able to feed in all the temporal data and have each have a kind of unique embedding representing that temporal area, representing that geographic area in this case, and then being able to like say like train in batches, have FlowForecast automatically train in batches where it kind of forecasts for say Chicago avocado prices in Chicago, and forecast for say New York or wherever the other geographic regions are. And some of the models actually already do this because they have series ID embedding. So it's really just a problem of getting our data loaders to be able to handle that. And then, like I said, once this is done, this will be another parameter you can swap in and out, which will be interesting. And there's even a lot of interesting stuff, like if you want to say, train on certain geographic regions clustered together in a row, or like spread it out. So there is even some optimization kind of strategies that can go into this. Going faster because I'm pretty sure I don't have a ton of time and I do want to have questions. Another huge thing is the kind of more advanced geospatial forecasting. So being able to train on similar to kind of the series ID thing, but actually leveraging the different geospatial relations between different entities. So in the case of river flow forecasting, if we could like find a way to embed the geospatial data of different stations and their actual geographic distances as kind of metadata, then we could forecast on many at once. Similarly, COVID, it would be good to learn the actual relationships between the different counties and how cases in one county affects the others based on kind of the geographical and transportation layout. And there are a lot of graph neural networks now that are starting to do that a lot better. Time series, we unfortunately haven't had time to fully implement those, and it will take retweaking some of our data loaders to be able to handle some of that advanced geospatial data. That's something we definitely want to work on. Another thing is just swappable kind of things. So like we already obviously allow a ton of different swappable parameters, but for instance, like certain data loaders will return, temporal things like day of the week, month, and they'll create actual temporal embeddings, but often those only work with a certain set of models. So we want to make sure that every model can, if people want, it can ingest all this different data. So people can actually tweak models almost a lot further than the original offers of the paper intended and see if that like improves or hurts performance. And another great area where people can help, even if you're not too familiar with our actual underlying code structure or anything like that, and don't have time to get familiar, because we'll be happy to help make you familiar if you want, is adding new examples and kind of benchmark data. Obviously, we have examples from COVID. I have the Avocado data set. Some others have contributed some economic forecasting data, but there's so many cool time series forecasting problems. So if someone just wanted to go, either you make their and had permission to make their company's temporal data public for a benchmark, or even using existing time series data set out there, but serially test FlowForecast on it with all of our different models, that would be really good. Oh yeah, and yeah, please everyone, please go star FlowForecast. I hate asking for it, but Github Metrics do actually wave repositories based on the number of stars. So unfortunately, other repositories that have better publicity have gone starred more, so they show up higher in search results. So we are trying to catch up there. So please help us out there, even if you don't have time to fully contribute or something like that. Okay, yep, I think I can go to questions now. Hopefully, yeah, I think there still should be some time to hopefully answer those. I know I ran through like a ton of stuff pretty fast. I guess, so are questions in the chat? Yes, they're in the chat. Trying to look through it right now.
Yes, okay, sorry, I just come back, grab a cup of coffee. Yes, you can go through the question in the chat. I see we have a few from top. I just quickly remind everyone, if you have questions, please enter in the chat. We go through the Q&A right now. If you prefer to speak, ask questions, feel free to raise your hand. We can unmute you to speak, to ask questions.
Okay, yeah, so I'll try to go through the questions in the chat, I guess, on chronological order. So, yeah, first one I see says, was it 5:51 p.m.? Pratik from the UK asks, sorry if I pronounce anyone's name wrong. I'm not great at this. Thanks for the talk. I had a question. Have you tried time series anomaly detection using both forecasting, VAFE, and reconstruction methods? In your experience, does one work better than the other? So I assume reconstruction based, you're talking about kind of almost like reproducing the original representation, like say using an autoencoder. Okay, so yeah, you're saying using kind of that like representation learning, using an autoencoder or something like that, or versus just forecasting. So yeah, I haven't benchmarked a ton on that. I think each has its own benefits. Forecasting, definitely, I mean, forecasting, if you think about in theory, it helps it learn future time steps, and reconstruction based helps it learn kind of its current state or representation. So yeah, I think each have its own benefits. That's why I'd be more interested once I get that new module rolled out to FlowForecast properly to test kind of a joint thing, like a joint autoencoder forecasting method that because there is something called a supervised autoencoder, which I've actually used before for representation learning, actually on genomics data, though not time series, but it might work here too. So moving on, any idea on how the representation learn, behave in time series similarity measurement? Yeah. So I actually did do some. I could even try pulling it up. Maybe I did do definitely some cosine similarity stuff. I haven't done it very rigorously, but I did found like when for instance, I did the representation version on it did actually do the function pretty well in differentiating representation, say between like a severe rain event and whatnot. Yeah, I don't think you'll be able to tell anything from this, but this is really messy. But basically here, I did briefly examine some of the quality of representations. But yeah, that's another thing I'd like to put in FlowForecast too, is an automated like representation similarity kind of visualization tool, so you don't have to run like all these complex, messy stuff outside of it. Then the second part of that was any benchmark on the M5 data set. No, I haven't actually done a ton of benchmarking on M5. Some of the original authors of the paper have. Here I'm been more focused on kind of this kind of novel time series where people haven't benchmarked on a ton. But yeah, if someone wanted to take all FlowForecast different models and benchmark them on M5, that would be really good. Question, could you summarize the main ideas, the main findings, and the main limitations in the main roadmap items? I don't know exactly what that's asking. I guess just in summary, the main ideas, I guess, so far is, well, I guess, I mean, the main ideas of this presentation are kind of all, I guess, say classification, forecasting, anomaly detection are all somewhat related. I guess FlowForecast helps you do it. There's still a lot of problems with hyperparameter optimization and kind of a lot of unexplored areas. As for roadmap items, we're trying to add things like GNNs, improve documentation overall, and add better leveraging of additional series IDs in batches. I guess that's how I best answer that. Hi Isaac, for how many months, years of data do you have? How big is that data set and what kind of information do you use in this particular example? I don't know exactly what I was talking about at the moment, but in terms of the river flow forecasting, it is a big data set. I have about 6 years of hourly river flow data for each station, combined with a similar amount of data, weather data, historical hourly weather data. There's actually I have a paper called FlowDB, which describes the entire river and stream flow data set. It's on ArcSiv if anyone wants to learn more about the river flow forecasting and weather data set, because that was quite a task in of itself to create. If you're talking about the COVID data set, that's obviously much more limited because COVID's only been going on like, well, a year and 10 months. So, and we only have daily data, so there aren't that many time steps. So most of the COVID stuff's actually been pre-training on a lot of different counties and then forecasting on a target county. Let's see, can FlowForecast work on data which is captured irregularly or intermittently over time? We don't have great support for that, but it is possible. We do have an automated interpolation library. I don't know if I actually showed any examples in the configs here, but we do have this in different interpolate parameters you can actually supply. So this like fills missing values with the closest value. Closing values. We don't have any models explicitly supported in FlowForecast at the moment. That specifically work on like irregular time series data where like even after filling you never have a consistent interval. That's something we might look to support in the future. But if you can just fill the missing values and do a consistent thing, you can definitely use just interpolate. But if it's entirely irregular, then not at the moment. How do you do anomaly detection time series as in general, in general anomalies or outliers? Well, as I was saying, if you have supervised data, of course, of like where people like labeled it or something's an anomaly, then you can train it in a supervised fashion. It's pretty hard with standard classification loss metrics though. That's why I was looking at explicitly at the focal loss and other things like that. There are a lot of non-deep, if you don't have annotated data, you would do something like I was saying, which is like creating like an embedding of the time series and computing the average distances between the different embeddings. There's a lot of non-deep learning methods to handle it too, though I won't go over those at the moment. Okay, I think that's all the questions. Does anyone have anything else? Oh, wait,
I think there is a question sent to me. Just reminder, if your questions should send it to everyone so the speaker can see the questions too. I think this one from Elysia, again, sorry if I say your name incorrect. But she or he is asking, what do you think about the use of autoencoder variations with CNN?
So wait, the question was asking about like combining an autoencoder with a CNN or?
Let me just post into the.
Yeah, I'll just read it in the chat. Okay, so I think this is asking about variational autoencoders. Variational autoencoders are obviously another potential thing. I haven't used VAEs too much. I know VAEs sometimes work. Well, I mean, I usually think of VAEs as kind of a generative model like GANs. So I'm not sure how great it is compared to a vanilla autoencoder. But yeah, if anyone has any research on that and they think it would work well, you can message me. But yeah, I don't actually know too much about that. In terms of like combining it with a CNN, yeah, I mean, an autoencoder, I mean, could the output of an autoencoder could go into anything, and some time series models do use convolutional layers, so that's definitely possible. Though I haven't done any of that explicitly here. But yeah, I don't know too much about the VAE angle. But yeah, it's possible. Are there any other questions?
Great, thanks. Yeah, if you have any last minute questions, we are a few minutes over the time, but it's fine. And again, if you have any questions, feel free to send in the chat. Let's go with maybe one more last questions, if any.